What's up, people? What's up? What's up? So sorry once again for being late. How are you guys doing? Everyone awesome? Welcome to today's session, people. So, how was your day so far? What's new in life? How's everything going? All great? What's up? Can you guys all hear me? Can you guys all hear me? Can you guys all see me? Is there any sort of technical issues? My internet was down for a second. That's why I was a little late. So, yes, can you guys hear me now? Yo, what's up, people? How's everyone? Great, awesome. Hi, Omkar. What's up, Dan? I'm so sorry for being late, people. So, what's up? How's everyone doing? Hi, Ayushi. What's up? Hi, Shri. What's up? Da? How you doing? Hi, Nidhi. Good afternoon, Anmolji. Is it afternoon? It's 3 o'clock. Da? It should be evening, no? But nonetheless, I forgive you. Hi, Adyasha. What's up? Da? Hi, Binayak. What's up, buddy? How you doing? Hi, Janki. Good afternoon. Da? Good afternoon. Forgot admission. Arey, congratulations, Anashri. High five. Super amazing news. Party. Congrats, da. Congrats. Hi, Omkar. What's up? So, walk mare do you know what is that? Do you know me? Please recall her. Okay, yeah, Omkar, I know that. How are you? Good evening, guys. What's up? Hi, Surya. Hi, Shita. Hi, Sayali. What's up, guys? Okay, anyways, welcome to yet another super awesome califragilistic session. I hope you guys are doing fantastically well. I hope you guys are having a fantastic day, a very productive day so far. So we are back with the Prodigy series. We are not done with the first term syllabus. So we are on to the third session of light, reflection and refraction, where we will be basically talking about scattering of light today. So people, in the chat box, can I get a loud, full Josh wala? Oh yeah. In the chat box, give me a oh yeah in the chat box if you guys are all ready. Yes, definitely yes, Binayak ji. We will have Menti. Without Menti, though, I can't even show my face. No, you guys will start, start protesting and stuff. So yes, Menti is definitely there. Yeah, is it? Congratulations, Prathima. Congratulations. Amazing. Good to know. I hope final exam also turns out to be the same. All right, people. Thanks a lot. So yes, let's get started. I want to start off this session with a simple riddle. The riddle for today is this. Everyone, think carefully. If you get this answer right, you know what? Nothing. If you get this answer right, good for you. The riddle is this. Only one color, but not of one size. Stuck at the bottom, yet easily flies. Present in the sun, but not in rain. Doing no harm and feeling no pain. What is it? Come on. I said yes, yeah, hi, thank you, Omkarji. Thanks a lot, thank you. White, no, wrong answer. Hi, Tamanna, what's up, how are you doing? Thanks a lot, welcome to today's session. White. What is white? No, white is not the right answer. Light is also not the right answer. Heat is not the right answer. Anyone else? Tejas, okay, Shre, congratulations. Rainbow, no, Naomi, it's not rainbow also. Heat. Why are you guys talking about? Okay, that's simple answer. That's very only one color, not a one size. Stuck at the bottom yet easily flies. Present in sun but not in rain. Doing no harm and feeling no pain. I mean, I thought you guys would be able to get this right in 3 seconds. I mean, you guys answer all the toughest of the toughest riddle, and this silly EGPG riddles. You guys. Okay, the answer to this riddle is shadow, people. Shadow. Because shadow is always black. No matter what the color of the object is, shadow is always going to be black. So it has only one color. And yes, it is present during a sunny day, but not in a rainy day because it's all cloudy. And yes, it does not feel any harm and it does not feel any pain also. Got it? Super easy riddle. What is this? I can only say this. SSPS. I'll tell you the abbreviation for this towards the end of the session, but don't worry about it. All right. So guys, let's get started with today's session. Now guys, let's talk about few scenarios. Imagine you're sitting in a room. All right. Imagine you're sitting in a room. Now, if you sometimes observe the light that is coming through the window or maybe a small crack, you would actually be able to see those rays of light. You can see the rays of light that is coming through the window. Maybe you would have probably seen this in if you're in a forest or something, you'll probably be able to see it, even the light that is coming between the leaves or maybe between the trees as well. You would have probably seen these rays of light that is coming. Maybe if you guys have the time, I mean, these days you don't really get out much during the evenings because you have a lot of online sessions and all of that. But yes, back in those days, remember those days when you used to go to school and, meet your friends and say hi to your friends and actually see them smile and scold them and stuff. So during those days, probably notice that during late evenings, that is, during the sunset, you'll probably seen these rays of light that is coming out from the sun. Again, certain rays of light. One more question that has been wondering, that we wonder a lot, is this: that why does our sky appear blue? Why does our sky appear red or orange during the sunset? Now, for all these questions that I just asked, for all these things that we just talked about, there's only one simple answer. And that answer, my friends, is nothing but scattering of light. In today's session, we're going to study exactly that. We're going to understand what is scattering of light, what are the conditions required for scattering of light to happen, and why does scattering even happen for that matter. Right? My name is Anoop. A very, very warm welcome to Vedantu's 9th and 10th English channel. I hope you guys have subscribed to the channel already. If you haven't done it yet, make sure you guys subscribe, all right, and like that video as well. All right, so guys, with that said, let's get into the Mentimeter first. We'll do a couple of questions from the previous session. We'll do a couple of questions and then we'll come back to the topic. Once we're done with the topic, we'll have another quiz time after the topic is done, right? So the code for today is this, guys: 675456. That's probably the shortest code of all times. 6754456. I'm not used to short numbers, but yeah, let's go. The code, you have to do this, guys. All you have to do is open up a new tab, enter www.menti.com, menti.com, and enter this code 97456. Let's go, people. Let's go. Come on. So how to love ourselves? Oh, it's very simple. Stand in front of the mirror and tell yourself this: I am the best. I am the best. That's all. You just need to accept the fact that you are the best. Nobody can replace you. That's all. You just need to understand that nobody can replace you. And once you have that feeling, you get that sense of control. And that control is what you need. So I have a doubt. Can you tell that why speed of light is different, of different colors of light have same speed in vacuum? Because Janki, all of them, see, in vacuum, there is no particles. There are no particles. What is vacuum? Vacuum is nothing but it's nothingness. You don't have any water. You don't have air particles. You don't have dust particles. There's nothing. So what happens is that because there's nothing to obstruct the wavelength of light, they will all travel at the same speed. They will all travel together because there is nothing to obstruct it. Now, when light enters into a different medium, there's a lot of obstruction given to it, and that obstruction is what is causing the refraction, and that is what is causing the dispersion of light as well. But in vacuum, there is no particles whatsoever, so they all travel at the same speed. They all travel at the speed of light, which is nothing but 3 into 10 to the power of 8 meters per second. All right. I know, right? The shortest code ever. I've never experienced that before. I never thought that is possible also. All right, so let's get started. 67456 is the code for today. 3 questions from the previous session. Let's go, people. Are you all ready? Okay, I see 30 of you guys there, 37 in the class. Whoever is here in the YouTube session right now, join the Mentimeter as well. Very simple funda. Open up a new tab and enter this code www.menti.com, menti.com. And once you enter, they'll ask for a code. The code for today is 67456. Once you're in, let me know, right? So shall we begin, people? Hello, Vanshikaji, what's up? All right, so I'm going to start the quiz, people, in 5, 4, 3, 2, 1. I hope you guys were there you were there in the previous session. If you haven't, it's still okay. See, super easy questions these are. The colored light that refracts most while passing through a prism is what? The colored light that refracts the most while passing through a prism is what? Red, yellow, blue, or violet? Which is the color that refracts the most while passing through a prism? Red, yellow, blue, or violet? You have 15 seconds. What a jujube question. This is laddu sawal. This is laddutwat sawal. Better. If you guys get more than 75% in all the questions, not all questions, or if we have 6 questions, so if we manage to get at least 4 questions more than 75%, then yes, bet is on. Whatever you say, whatever you ask me to do towards the end, I'll do it. All right? Deala, no deala. That's all. Deal or no deal. 75%. I'm not going to go any less than that. I'm done humiliating myself again and again and again. 75%. Do we have a deal, people? Do we have a deal? Yes, pakka. No going back. After that, don't tell me, sir, please make it to 70%. Please make it to 50%. No. 70 is 70. That's all. I'm not going to go any more lesser than that. All right. 70% is last. All right. So first question, people. 30 of you guys got it right. That's 73. So I said 75. All right. I said 75%. All right. 73%. Not bad, but not that great also. But still, it's a good start, people. It is violet. Violet is the one that refracts the most because it has the lowest wavelength, and red is the one that refracts the least because it has the highest wavelength. So good start, but not good enough. I still win. So it's 1-0, 1 for me. All right. And yes, no cheating. 75. That's all. Nothing less than that. All right. I don't ask me. That's it. I'm done humiliating myself. The whole world can see me humiliate myself again and again and again. I don't want to do that anymore. All right. Kevin was the first to answer. Congratulations, Kevin J. Good start. Then it's Krishna on the second, Kritish on the third, fourth is Aradhya. Then it's Anmol Preet, followed by Sakura, followed by Krishananda, followed by Abir. Thanks a lot, Mishti. I have no idea how to read Malayalam, but whatever it is, I hope it's good. I hope you're not scolding me. As long as it's not, high five. Then it's Amisha as well. Congratulations. Well done, people. Good start. Second question. Seriousness on my face. Second question. Here we go. The question is, reflection of light by the Earth's atmosphere due to variation in air density is called as what? Refraction of light by the Earth's atmosphere due to variation in air's density is called as what? Options are atmospheric reflection, atmospheric dispersion, atmospheric refraction, scattering. Is that the actual spelling of scattering? It's catering. It's more like catering. Catering service, like light will come to your home and put some puri on your plate, some little bit pav bhaji and all that. That is what scattering is. That is scattering of light. This is not scattering. This is catering of light. Anyways, 30 to 33 of you guys got it right. Congratulations. Well done, people. Well done. Not bad at all. Overall, that's about 73%. I don't know. Should I be happy or sad? I don't know. But I'm still going to be happy about this because the fact is, you guys have defeated me enough number of times. Let me win at least once in a while. So I'm happy for this. 73%. Once again, it's a very good number, but unfortunately, it is not 75. But the answer to this question is atmospheric refraction. It is nothing but refraction of light when light enters from one medium to another. And here in this case, because air has different densities, each layer of air has different densities, the light ray bends multiple number of times, and that is what is called as atmospheric refraction. Congratulations, guys. Not bad at all. 73% to 0. Congratulations. I like it. Kevin still on the top, I believe. Or is it Krishna? Kevin, what happened from first all the way till 9th? Krishna moves to the top. Second is Kritish, followed by Anmol Preet, followed by Abir. Then it's Krishnananda, followed by CSK versus RCB. Oh, okay. Got it. Then it's Arnav, followed by Sakura, followed by Kushi, Kavin, and Sakib. Sakib Ji, welcome to the leaderboard. Super amazing. Super duper effort as well, guys. Last question from the previous session, after which we'll get into today's topic. So here it is, guys. Your quiz starts in 3, 2, 1. Let's go. Third and the final question. The first question. Which of the following is a natural phenomena in which is caused by the dispersion of sunlight in the sky? Let me repeat the question. Which of the following is a natural phenomena which is caused by the dispersion of sunlight in the sky? Options are rainbow, twinkling of stars, advanced sunrise and delayed sunset, or stars seems higher than they actually are. Which of this is caused by atmospheric dispersion of light? All right. 10 more seconds. Let's go, people. Let's go. Hi Anjali, what's up? How are you doing? Did I miss out on anything important? Oh, is it arcade sport? Congratulations. All right, 34 of you guys. Congratulations. One more time, people. Congratulations. And that is once again, just missed. Like 75, 76, just miss. All right. Anyways, congratulations. Not bad. Just I really was like, okay, that's it. Today's challenge is done. But no, You guys still have some fight left in you. 76%. Absolutely wonderful, guys. Absolutely wonderful. No worries. I'll still win it, I know. But the answer to this question is rainbow, people. It is rainbow because rainbow is something that happens because of dispersion of light. Light gets dispersed in that water droplet, creating this beautiful arc which is known as your rainbow, right? So congratulations. So far so good. Let's see what happens after the topic is done. We have another quiz time, but after the topic is done. So guys, with that said, I need 100% of your attention right now. Everyone, can we get another oh yeah? If you guys are all here, show that we can get started with the topic, and then again after the topic is done, we'll again come back to the quiz. Yep. Leaderboard, I'll show you the leaderboard. I'll show you the leaderboard after the first this thing, all right? After the once we're done with this topic, all right? Okay. Yes. 1 second, guys. Me. Okay. Yes. Let's go. I'm ready now. Let's begin. Okay. What is scattering of light? Let's talk about that first. Imagine, guys, a light ray is going straight. Now, light ray always, a ray of light, the natural tendency of light ray is to always travel in a straight line, also known as the rectilinear propagation of light. Light prefers to travel in a straight line. Now, when this light is traveling in a straight line, imagine there is one dust particle, or there is some gas molecule, or there is some water vapor on its path. Now, what will happen is that light is not like us. Light is not like, oh, there is a dust particle, I have to slow down right now, or else the police officer is going to find me. Nah, he doesn't care about all that. There is no police officer who can track the speed of light or the way light is traveling. So what happens is that, unlike us, light will go and hit this particle. Now, when the light ray goes and hits or collides this particle, it goes and hits this particle, what happens is that the path of light gets deviated. It, as soon as it strikes the dust particle, it splits or gets dispersed. It basically not dispersed and dispersed. It gets deviated from its original track. This deviation caused by the dust particle or by that water vapor or by that gas particle, that is what is called a scattering of light. Now, again, why does scattering happen? It is because of this. It is because of the dust particles, and we have a ton of dust particles in the atmosphere. In our atmosphere, there is a lot of dust particles. So imagine those rays of light that is coming from the sun. Won't they collide with these particles? Absolutely yes, because there are so many dust particles in the atmosphere, and that is what is causing the scattering of light. Now, this phenomenon of scattering of light was actually discovered by a person called as John Tyndall, and that's why it's also known as the Tyndall Effect. All right, so if you ever see the word Tyndall Effect, or if you ever see the word scattering, it means the exact same thing. So if you ever see the word explain Tyndall Effect in your examination, or if you say explain scattering, it's the same thing. Tyndall Effect and scattering mean the exact same thing because it was discovered by a scientist called as John Tyndall. It was also renamed. It was also named as the Tyndall Effect. Okay, now let me show you an example of it. Imagine that I have a laser light. Imagine, or let's say I have a torch, whatever you want. Now, what happens is that if you look very carefully, can you see the light rays in this solution? Now, let's say this is water and this is, let's say, milk. All right, this is milk mixed in water, milk plus water, and this is just water. Now, my question to you people is, can you see the light rays in the water chamber? Can you guys see that? Is that possible for you to see it? Can you see that ray of light passing through it? Now, light is definitely passing through it, but can you see it? Obviously not. Why? Because light is not getting scattered. Now, so there is a certain condition that has to be followed or that has to be satisfied in order for you to see this Tyndall effect. And that is that the particles that are there should be colloidal particles, or the solution that you have must be a colloidal solution. Now, what is a colloidal solution? Let me tell you that first. In chemistry, guys, colloidal solutions are nothing but those particles where the size of the particle would range all the way from 1 nanometer to 1000 nanometer. So if a particle size is somewhere between 1 to 1000 nanometers, that kind of solution is what is called as a colloidal solution. So if you talk about milk when it's mixed with water, the molecules of milk, the atoms and molecules of milk are much more bigger than that of pure water. So in pure water, the particle size are much more smaller, but in milk, it's a lot more bigger. And that is what makes this Tyndall effect possible. Because if you see clearly, you can't see the light path in water, but however, you can see the light path in the solution in which you have mixed some milk into that water. So remember this, guys, you need a colloidal solution. And what is a colloidal solution? Any solution in which the particle, the atoms and molecules inside that solution, if they range all the way from 1 to 1000 nanometer, that would be called as a colloidal solution. Examples are milk mixed with water. You can also talk about, sand mixed in water. You can also talk about apart from that, what is it called as chalk powder, the chalk powder mixed in water. All of these can behave like colloidal solution because, again, the particle size are much more bigger over there. And so here what is happening is that you are getting, because of these big particles, like I told you before, when light goes and hits these particles, it is getting a change in the direction. The deviation of light is happening because of these particles, and that again is nothing but your Tyndall effect. So you can see this very clearly over here in this video. So you can see that that is nothing but milk. All right, that person has mixed some milk in water, a little bit of milk in water, and you can see the clear path of light. Why are you able to see it? Because the milk that is there is a colloidal particle which has a size between 1 to 1000 nanometer. Got it? Is that clear, people? Absolutely understood. Yes or no, guys? Yes or no? Or do you want me to repeat it one more time? Is the definition clear? Did you understand what is the condition that has to be? Example is nothing but this, milk mixed in water. You can see there's no. So when milk is mixed in water, the milk particles, see, you're mixing another particle. So it's basically, you're making a solution of something. You're making a solution of something where the particle size of that solution is much more bigger, or is somewhere between 1 to 1000 nanometers. And when the particle size, remember this, when the particle size is between this, you see that light, when it goes and hits those particles, it gets spread out, and that spreading of light is what is called as scattering of light, or in simple words, Tyndall effect. So this spreading of light is what is called a scattering of light. And apart from that, this was discovered by John Tyndall, and that's why it is also known as the Tyndall effect. All right. So done and dusted, people. That was the first part of the topic. I hope you guys have understood this, because guys, here's the thing now. If you've understood what is scattering of light, now remember, guys, one thing that you must remember is that there is a clear difference between scattering of light and dispersion of light. Dispersion is the splitting of light into 7 colors. All right, dispersion is the splitting of white light into 7 constituent colors. Scattering of light is the spreading of light, because it is, going and collide. It's like, okay, I'll give you an example for all those who are still a little hazy about it. No, imagine you have, let's say you have a, like in holy time and all, you have this, you take a balloon, you fill it up with some color and stuff, you put some water into that balloon and mix some color into it and throw into people's head. Have you guys done that before, at least once in your life? Happy birthday, Ade. Seema, my birthday is long danda. Oh, sure. Yeah, okay. Janki, it's okay, it's okay. Sure, no worries. Yeah, yes, ma'am. Pranjal. Yes, what? Yes, ma'am. In which angle? I even have a beard to show that I'm a guy. Why do you guys call yes, ma'am and all? Like, what is this confusion? I don't understand. I have a beard also, da. Can you see it? I'll pull it down also if you want. Look at this. Hey, ma'am, it's all right. Anyways, listen carefully now. As I was saying. So what happens? What was I saying? That? I was saying something. So yeah, imagine that balloon filled with water. Imagine that you take this balloon that is filled with water and you throw it on a wall. What would happen? As soon as the balloon goes and hits the wall, the water would get spread out. Right? It would get spread out. Why? Because the wall is coming on the way. The balloon wants to go in a straight line, but the wall is coming on its way. So what will happen? As soon as the balloon goes and hits the wall, the water gets spread out. Imagine that the water balloon is a ray of light. So when that ray of light is going, imagine this wall is now a single particle, a very small particle which you can't really see. these colloidal solutions are very small that you can't see. 1 to 1000 nanometers, very, very small. You can't really see it with your naked eyes, right? So when it goes and hits this particle, it spreads out. It gets spread out just like that water that is there inside the water bottle, inside that balloon, right? That is what is called a scattering of light. Got it? Is that clear? Yes. So Katappa, what is that? Katappa chali karte ho sir. All right. Yeah. Is it clear? 100% understood? Is it because? Congratulations, well done. So what is the size of the particle is more than 1000 nanometer? Then that is not a colloidal solution anymore. If it's between 1 to 1000, then it's a colloidal solution. You have three types of solutions, right? I don't exactly remember it. I think the best person to answer that would be your Shilpi ma'am, because there are three. I remember there are three types of solutions. One, I believe, is a clear solution, which is nothing but what? What is a clear solution called as? I'm not really sure, but I don't remember that chemistry part of it. What is it called as a clear solution where you have homogeneous substances? What is it called as? A substance in which you have only the same type of atoms and molecules. What is that called as? Anyone who remembers that? True solution. True solution. No. Not pure. The pure impure is that you study in your 8th standard. But yeah, true solution. It's called as a true solution. True solution, colloidal, suspensional solutions are all. Yeah. So it's basically that. So depending on the size of the particles, you would have, depending on the size of the particles and type of atoms and molecules, you would classify them as true, colloidal, and other type of solution as well. Yeah. Homogeneous, heterogeneous, though, that depends on what does this, homogeneous means those solutions in which the particle is thoroughly mixed. Heterogeneous would be in which it is not completely mixed. So it will be like that. All right. Anyways, let's not get into the chemistry part of it. You have Shilpi ma'am for that. All right. Let's get back to the topic. Now, the question. Why is sky blue? To be honest, guys, for a very, very long time, when I was in my, probably till my 10th standard, to be very honest with you guys, till my 10th standard, I did not know the sky was blue because of this particular reason. I believe that the sky is blue because the water is blue. How many of you guys had this misconception, or probably you still believe that? How many of you guys still believe this, that the sky is blue because the water is blue in color? That is the reason why why sky is actually blue? Yeah, you guys still believe that? No, a lot of you guys still believe it. Now the fact is, guys, water does not have a color on its own. Water does not have a color on its own. So what is the reason that the sky is blue? Let me answer that question. Let's say that light is coming from the sun. Now this light that is coming from the sun has different wavelengths. It's called as an electromagnetic radiation. That is, it has all these different colors: your violet, indigo, blue, green, yellow, orange, and red. You have your X-rays, gamma rays, radio waves, microwaves. All of these light that is coming from the sun contains a mixture of all of these. It is like an avial. Avial is like a dish which is horrible tasting, where they put all the vegetables in at once. All right, it's like they put all the vegetables in the world. All right, they just mix it up all together and they just tell you eat it because it's good for your health. That's what they do. Same thing, light is like that. Light has so many things in it, but all we see is the visible spectrum of light. What we see is the visible spectrum of light. What we see is only violet to red. That is between 400 nanometers all the way to 400 nanometers to 700 nanometers. This is what you see. It's not exactly 400. It starts at 360 something around that, and it's around 645 something around this, right? So all the way from 400 to 700 nanometer is what you see. Now here's what happens. When that light is coming and falling onto the Earth's surface, because of these dust particles, because of the water vapor, because of the gas particles that is there in the atmosphere, what happens is that the shorter wavelengths of light. Now remember, light that is the light that you see is the visible spectrum of light as a combination of all these 7 colors. Now here, violet is the one that has the least wavelength. And as it goes up, the wavelength is increasing slowly. And red would have the highest wavelength because slow, it's like it's an increasing order, ascending order. That is, from violet, it is slowly increasing. So here's what happens. The shorter wavelengths of light, the shorter wavelengths are violet, indigo, and blue. These 3 colors would easily get scattered. They would easily. In fact, violet and indigo gets even scattered even faster than blue. So what happens is that blue gets scattered the most. Now you have all these colors, but what is happening is the shorter wavelengths of light, that is especially violet, indigo, blue, they get scattered the most. Especially when it comes to blue, it gets scattered the most. So it's somewhere like, violet and indigo are so, the wavelength is so less that it gets scattered very easily. Blue, on the other hand, is somewhere in between. So what happens is that it gets scattered the most, and thus giving you this impression that our sky is blue in color. It is because of this scattering of light. Again, it is because of scattering of light and nothing else. Now, one more thing you need to remember is this, guys. As the light rays passing through these layers and layers of atmosphere and reaching the Earth's surface, because of all these dust particles, there is some decrease in the intensity. The brightness of that light also gets decreased because there's a lot of loss happening. That as the light is traveling through this dust particles, there's a lot of loss happening. It is getting scattered. So there is loss happening every single time it hits a dust particle. There is some loss happening. There is some refraction also happening. Because of this scattering, because of this refraction, the intensity, that is the brightness that you actually see, is actually a lot lesser than what the actual source of the light is. So you get a lot less intensity when you compare it to, imagine if you're standing on the International Space Station somewhere over here, the intensity of light would be much more greater over there. But on the Earth's surface, it would be a lot lesser because as it's coming through the atmosphere, it's also getting scattered a lot. Got it? Is that clear, guys? So what is the real color of sky if sunlight would not reach the Earth? Real color of the sky would not have any color at all. If there was no sunlight, at all, sky would not have any color at all. It would not have any color at all. Basically, if for a person who's, for example, if there's a scientist or an astronaut, if he's seeing from space, he will not see as, the sky is white. He will not see it as white, or so he will not see it as blue in color, because there is no scattering of light happening over there, right? So for him, sky is not blue at all. So it's an illusion which is caused because of scattering of light. It does not really have any color at all. It has, basically it's black. It's black. So for an astronaut who's seeing from the outer space, for him it will look like black because there is no scattering happening. There is no light reflecting and falling into his eyes. So it seems like it's black. But for us, we see it as blue because of the scattering of light. Got it? So why sunray is orange but sky is blue? See, that is what I'm trying to tell you, winners. Because there is the light that is coming from the sun is okay. Let me ask you this question. How many of you guys believe that the actual color of the sun is orange or it's yellow? How many of you guys actually believe that the sun's color is actually orange or yellow? How many of you guys, like all these pictures, because from your childhood days, you've been seeing the color of the sun. How many of you guys believe that that is actually the truth? The fact is, guys, let me tell you, your whole life was a lie. Sun is actually white in color. Sun is actually white in color. But again, because of the scattering of light, we see it as yellow or orange. But the actual color of the sun is white. So for an astronaut, again, if I talk about an astronaut, again, because light is not entering through any medium, light is traveling in vacuum. There is no dispersion of light happening. There is no scattering of light happening. So for him, the sun would appear white. But for people on Earth, it appears as though it's yellow or orange. Again, it's because of scattering of light. Got it? Is that clear? So what you see is not what is actually existing. That's what I'm trying to tell you. So here also, the light that is coming from the sun has all these colors, but only the lower wavelengths of light, that is violet to blue, which has a lower wavelength, is getting scattered the most in comparison to all these colors. All these colors, green, yellow, orange, and red, they are reaching the Earth's surface. They are not getting dispersed. So you don't see those colors. Getting it? Okay, let me give you another example. Why are you able to see this cap as green? Why are you able to see this cap as green? Let me tell you why. When light falls on this object absorbs all the colors and reflects back only green. That is why you're able to see it as green. Why are you able to see, why are you able to see this as pink? Again, because it is absorbing all the colors and reflecting only one wavelength of light, which is nothing but pink. That is why you are able to see it as pink. So the colors that you see is nothing but the property of the object to absorb all the other colors and reflect one particular color. So here, so all the other colors are reaching the Earth's surface. So you don't see those colors. But blue, on the other hand, gets scattered the most, so you see it as blue. Got it? Clear? Why it only reflects green? That is because of the atoms and molecules, the arrangement of the atoms and molecules that are there. They are able to absorb those wavelengths of light and reflect back only that color. All right, that would be getting into physics more. No, sorry, that'll be getting into chemistry more of it. All right. I'll tell you that also already. I'll tell you that also. So that is why, guys, that is why you see that, light, the sky that you see is always blue in color. It's because of this one particular reason. Okay, one more question, guys. One more question. All these danger signs, any danger sign you take in the world. Stop hitting the mic. I'm so sorry, Mike. All right, I'm so sorry. All right. Now, here's the thing. Let's say that let's say you have a danger sign. No matter which danger sign you see in the world, all danger signs in the world are red in color. Be it the red light, be it a light that is there at the back of a train, be it a light that is there to show the path for an airplane, all of them are red in color. Why are they red in color? The reason why they're red in color is because, guys, red light has the highest wavelength. Since it has the highest wavelength, it can travel a much more longer distance compared to all the other colors. It would travel a long way before it gets scattered, because the wavelength of red light is so high that it easily does not get scattered. It does not get scattered. Even if you have dust particles in between, it does not easily get scattered. So it can travel a much more longer way compared to yellow light or blue light, which easily gets scattered. So that is why, guys, you can see red from a very, very long distance. So when you see a stop sign, the reason or why you're able to, for example, you're like half a kilometer away, you can still see the red light signal, the red light on the signal. Why? Because of this red light can travel a longer distance because it has larger wavelength. So you can decide in your mind that, okay, there is a stop sign, so I have to start applying the brakes. Or if there is any sort of danger, you would know that, okay, there is some sort of danger in front, so you can start taking actions right away. That is why you see it as red in color. Got it? That is why. Exactly. Red has the longest wavelength, and hence it can travel the longest distance also. It can travel a longer distance without getting dispersed as much compared to all the other colors that you see. Be it even if it's foggy, that is why your tail colors, the tail light that you have, they are also red, because the person who's behind should be able to see if you have applied the brakes or not. All of this, again, there is a scientific reason behind it. It's not like they were like, one day they woke up in the morning, they're like, okay, which color should I put for tail light? I like violet. Violet is a lot, like violet is a lot of pretty colors. I like violet a lot. So why don't we put violet? They don't do that. There's a specific reason for it. And that is because of this. Because red can travel a longer distance. It's not because they're not playing God by waking up in the morning and they're playing, okay, inky, pinky, ponky, which color do I want? Which is this thing that color, which color? They don't play all that. All right, that's because red has a longer wavelength. That is why it can travel a longer distance. That's why they choose red. There is a scientific reason behind it, and that reason is this, that it has a longer wavelength. All right, so red would scatter the least in comparison to all the other colors. Right, guys? And yes, one last thing before we get into Vedantu part, let me also tell you why, guys. Why is it that the sun appears orange or almost reddish in color during early sunrise and delayed sunset? Again, the reason is scattering of light. So what happens, guys, is that during the sunset, if this is the Earth, the sun is at an angle. The sun is at a very, very low angle. It's at a very, very low angle. So what's happening is that the light that is coming from the sun is now going through a lot more dust particles. It has to go through a lot more dust particles, which is there in the Earth's atmosphere. There are a lot of dust particles because it's coming at an angle. So they're basically colliding with a lot more dust particles. So because of these collision with a lot more dust particles, what happens is that all the other colors also get easily dispersed. They are also getting easily scattered. Violet, indigo, blue, green, blue, all of these are easily scattered. what scatters the most at that time is yellow and orange. Just like how blue got scattered the most, here orange and yellow gets yellow and red. These wavelengths of light, the higher wavelengths of light, would get scattered a little bit more because of the size of the dust particles, because of the amount of dust particles being more, and that is why, guys, you see it as orange or red or yellow in color, especially early in the morning and late in the evenings. You don't see it in the during the day, during midday, during noon time. You don't see it as orange or red because the sunlight is falling at it is falling almost at 0 degrees. It's falling at 90 degrees to it's falling normally, in other words. So if it's falling normally, you don't see it, but when it falls at a certain angle, when it's falling obliquely, it is passing through a lot more dust particles, a lot more scattering of light is happening, and hence, guys, you see that there is all these shorter wavelengths, violet, indigo, blue, and yellow. Blue gets scattered the most, and they get scattered very easily. Yellow, orange, and red would get scattered the most over there. All right, so yeah, guys, that's why. So sometimes moon also appears yellow. Why? Anubhavji, that is just because of something else. That is not because of it has got something to do with scattering, but it's also because of the fact that, see, moon you're able to see because of moon is not a luminous object. Moon is a non-luminous object. So because of scattering of light, see, again, there are certain conditions for that to happen. There are certain conditions. So when the light that is coming from the sun is getting scattered and falling on the moon, and then it gets reflected back, that is how you're able to see it as orange or orange in color. It's not that because, again, moon is not a luminous object, it is a non-luminous object, so it just reflects the light or absorbs the light and reflects it back. In this case, the light that is coming from the sun is scattering, falling on the moon, and then falling into our eyes. It is reflecting back and falling into our eyes. That is why you're able to see it as orange in color. But again, that is not something that you're going to be dealing with in your 10th standard, so you don't have to worry about it. Chill out. All right, sir, why does atmospheric refraction happen? Seema, atmospheric refraction happens because our atmosphere, our air particles, they keep on changing the densities. For example, like I keep saying this example, that 1 minute it's all sunny, next minute it starts raining. 1 minute it's raining, and the next minute it's a very there's a very fast wind blowing. So our atmospheric condition, that is your weather, keeps on changing every time. So there's a lot of factors that affects it, and because these factors are constantly changing, the density of the air is also constantly changing, and because the density is changing, the refractive index is changing, and because the refractive index is changing, atmospheric refraction happens. All right. So does light travel in a straight path? Yes, Krishananda. Light always prefers to travel in a straight line. That is what is called as the rectilinear propagation of light. Light always prefers to travel in a straight line. All right. See, that is what Mayanji, that is what in most days what happens is that the light that falls on the moon gets reflected back. It gets reflected back, or it absorbs some light and then reflects back. It absorbs some light and reflects back, or the light that is coming. See, obviously, when it's like, what do you see? There is if, for example, if the moon is over here, the sun is over here, the earth is over there, the sun would be somewhere over here. So light is coming in all direction. No, so what will happen is that the light would bend a little, reflect, and fall into our eyes. That's what generally happens. That is how you're able to see the moon. That's why you have different phases of moon. If moon was a luminous object like our sun, you would not be able to see different phases. You have different phases in moon. You have full moon, you have crescent, you have all these different phases, right? You have all these different phases of moon. We are able to see that because only a part of that light that is falling on the moon is reflecting and falling into our eyes. Not every part of that moon is, it's not that the moon is not complete. Moon is still there, but the fact is that the sunlight is not reaching there, it's not getting reflected back, because moon is also revolving, earth is also revolving, right? So because of all these factors, that you're able to see different phases. So that's same thing now. So that is how you're able to see the moon. All right. So if energy cannot be created or destroyed, then how did the Big Bang happen? That's a different conversation altogether. Let's not get into all of that right now. All right. Let's talk about Big Bang after. Let's do the quiz question first, and then do the Big Bang after. All right. Let's do the Big Bang after. We'll talk about it. Don't worry. It's a very interesting topic, but let's not get into it, because if I start talking about it, then I won't stop. I'll extend the session till 5 o'clock. So let's just chill out. I'll come back to that, but let's first solve the quiz questions and everything. All right. So guys, here's the thing. Let me also tell you something very important. See, guys, if you are feeling like you guys need more help, if you guys feel like if you need more help in your exam preparation, you feel like you can do a lot better with more, more personalized attention and with a little bit more effort from our side, you can always enroll into the Vedantu's Pro subscription courses. So let me just quickly take you through that. Vedantu's Pro subscription courses is not like your YouTube sessions. Now in YouTube sessions, what happens is that majority of the times your doubts go unanswered. Sometimes I am not able to get enough time, or maybe there are so many doubts coming in, so I might miss out on your doubts. Now all of these are problems that we have in on YouTube, which cannot be easily resolved. Apart from that, it's not always possible for you to take the quizzes also, because you have to open up a new platform like Menti and take part in all these quizzes. Now all of these problems have been solved, resolved, and made even better on the Vedantu platform. So let me tell you how it's done. Vedantu's platform would look something like this. So once you enroll into the sessions, this is what it would look like. So you can check out all of the past sessions. Every session is live. So once the session is done, you can always check out the replays. So if you just click on this replay button, you guys can check out whatever happened in that entire session. Throughout the entire session, whatever has happened, you guys can check that out. So let me just show you one of the sessions that happened recently in any. So if you just go to some session that happened, I think a couple of days back. So this is one such session where you can see that you would have a completely different platform where you guys can, study for your term one preparations. Because again, it's very important that you, even if you haven't started yet, it's very important that you start at least now, so that you guys can, better prepare yourself, better equip yourself in understanding the concepts before your exams start. So that is the sole intention of these term 1 crash course. This term 1 crash course will be there throughout the entirety of your exams until your term 1 examinations are done. These classes would go on all the subjects: physics, chemistry, bio, social science, English. All six subjects would be taught completely, all the way from the first chapter, including revisions, including test series, including assignments, including notes of every session. That is what you're getting at Vedantu, including the notes. I know that a lot of the times notes are also not being uploaded, but here you don't have to worry all about all of that, because your notes would also be there with you at any point of time. So this is what the sessions would look like. You guys can check out the replays. You have something called as a leaderboard. You have the fastest fingers list after all the questions, so you can actually actively check how well you are doing in that session. Actively you can keep an eye on how your performance is, and you can see and improve throughout those sessions. And also, more importantly, these questions might also appear in your board exams as well. So it's very important that you attempt these questions when you are in the session as well. So you can check out this is how it's going to be, and you can also download whatever is written on the note, guys. That is whatever is written on the whiteboard. If you just click on get notes, so this session happened on 18th of September, that was 4 days ago. So once you click on get notes, you can download the entire notes and see for yourself how the notes are going to be. You can check out every single detail, whatever is there in the session, all of that can be downloaded. Apart from all of these, you can also take part in the quizzes while watching the replay also. If you go to my replays, if you just go to click on replay, and if you just click on try alternate replay, guys, you can even check out the quizzes while watching the replay as well. If you want to just try it out one more time, you might not have done so well in the regular session, but you want to try it out one more time, you can even take part in the quiz while watching the replay also. You guys can take the quizzes and check out your leaderboards as well. So all of these, again, small techie gimmicky stuff which would help you to become better and help you to understand the concept in a fun and interactive manner, and that is what Vedantu is all about, right guys? So you can check it out all over here. You can also enroll into micro courses, which are absolutely free for all the long-term students. So if you click on micro courses, you'll have lots and lots of sessions where you have, for one particular chapter, let's say you're finding light a little bit more difficult and you want more help, you guys can enroll into the micro course for free of cost, and you guys can take the quizzes and study the entire chapter one more time over there, right guys? So lots and lots of options. You can download all of the content, you can see the test, you can check out how your entire entire session calendar is going to be, what timings are it. Again, you can study in a language that you're comfortable in. If you're comfortable in English, you can study in that. If you're comfortable in Hindi, you can study in that as well. So lots and lots of options is what you have. So all you have to do is this, people, just go to the video's description. I think I'll be able to see myself right now. Yes, where is my cutie pie? Yes, cutie pie. I look so cute, no? I know. So anyways, so if you just go to cutie pies and click on, first of all, like the video. I like that, all that dislikes, no? Once you come out, I'll show you. So click on the like button, subscribe to the channel as well. So what you do is, guys, click on CBSE Term 1 Crash Course. Once you click on this link, it'll directly direct you towards the Vedantu's website, where you can check out all of the details for yourself. Now, there are two important, classification, or two different types of, features that you have. One is Vedantu Pro Lite and Vedantu Pro Classic. Vedantu Pro Lite has all the basic features, live interactive sessions, test series and assignments, everything that you have. But the only backdrop is that you do not have the doubt solving app. So you don't have the opportunity to get your doubts solved outside the session, but your doubts will be solved inside the session as well. You can check that out also. For example, if I go to, my sessions and just check on the past sessions, you can see that all of the doubts are cleared right there and then. For example, if I go to that light chapter itself, if you just go and scroll down, there were about 194 doubts that was asked in that session, and all of that 194 doubts were resolved inside the class itself. So you have that opportunity already available absolutely with the courses that you take. But if you want more doubt solving extra help, you guys can get into the classic. Now again, guys, the classic and the difference is hardly 400 rupees, 450 rupees is the difference. So Vedantu Lite has everything that you need, all the basic features. Again, this is until the end of your exams, that is for the next 2.5 months, with all of the 6 subjects, including tests and assignments, including MCQ questions, including your assertion reasoning type question, case study based questions, revision, all of them together is what you're getting over here. In Vedantu Classic, the price would be around 4,950, which would be around 450 rupees more. But you also get the Vedantu's doubt app, so you can get your doubts solved whenever you want, 24/7. There are more than 250 doubt solving experts who are waiting to solve your doubts. All you have to do is take a photo and send it in the app, and your doubts would be resolved, right? So yeah, all of that is right there. Again, guys, it's only what I'm trying to say is that, see, this is just another path for you to get to where you want. I'm not saying this is the only path, this is the only thing that you have out there. No, I'm not saying that. But yeah, this is one of the best things that you can opt for, because you have a very affordable price for all 6 subjects. That means that per subject you're not even paying 1,000 rupees. It's less than 1,000 rupees. If you go with Vedantu Classic or Pro Plus, whatever it is, it's 4,500. That's less than 1,000 rupees per subject for the next 2.5 months, including revision and the entire chapter as a whole. That's a lot, right? So yeah, you can check that out as well. Now let's get back to the Menti now. By the way, once again, all those who have just joined it right now, please, go to www.menti.com, menti.com, and enter the code 67456. I'm not used to small numbers. All right, 67456. Once you're in, let me know. So again, guys, this is what the leaderboard stands after that question. Krishna followed by Abir. Then it's Arnav, who was the fastest to answer the last question. Anmolpreet, Sakura, who was the fastest again. Sakif, followed by Kushay, followed by Kritish, and Amisha, and then Krishananda. All right. So guys, let's go to the next question. But before that, once again, I'll take a break. I'll take a small 30 minutes break. You guys can join back the Mentimeter quickly, because I can see that only 24 of you guys are here. So quickly join back the Mentimeter. Once you guys are in, let me know. All right. So there is no scattering of bending of light on space. Then does the bending take place? I see. The Earth is a sphere, right? Earth is a sphere. Okay, there is something called as diffraction of light. Mayank, that's a different concept. That's why I don't talk much about it. Diffraction is a simple concept where you see that light is bending around corners. All right, diffraction is a concept where light is bending around corners. Now, that is a concept that you'll study in your 11th and 12th. All right, there's something. So all this while, what we have studied is that all throughout this grades, you have studied that light always travels in a straight line. But sometimes it so happens that light can also bend around corners. So that diffraction of light is what is happening over here. Getting it? So light is, because Earth is a sphere, light is bending around the around the surface of the Earth as well, around the Earth as well. So there's bending of light happening as well. That's why I don't talk much about it, because it's something that you guys need to understand in your higher grades. So there's a whole chapter for diffraction. When you go to your 11th and 12th, you'll study about polarization, Young's double slit experiment. You'll study about diffraction. There's a lot of properties. Light has a lot of properties. What we have studied about, reflection, dispersion of light, scattering of light, these are only a part of it. There are so many different properties of light, right? That is why light is called as dual properties. It is considered as both particle and wave, because you can't explain all of these properties as one thing. That's why. Got it? So yeah, exactly, Mayank. There is see, it's not, that is not the only factor, but yeah, that is one of the factors as well. That is not the only factor, but that's one of the factors for sure. All right. Okay, guys, I'll start the quiz in 5, 4, 3, 2, 1. Let's go. Come on. Let's go. One cannot see through a fog because of what? What is the reason that you can see on a foggy day? A refractive index of fog is very high. Fog absorbs the light. Light is scattered by the water droplets. Light suffers total reflection at droplets. What is the reason for it? Come on. Yes, Toji, I am a Malayali now. So I haven't studied particle nature. That's what Arnav. That's what I'm telling you. You guys haven't seen through a lot. So this is only a part of it. There's only a very, very small portion of light. There's a lot more that you study in your higher grades. That's the whole point of, going into the next level, no? Nice, well done. Super awesome. Excellent. How much is that? How much is that? Wow, bete, 41%. Oh, so happy day. Why? Fog is, what is fog? Fog is basically because when the temperature is too low, the water droplets basically drop down, because it becomes very heavy, because it becomes very, very cold, that it becomes much more denser, and it basically drops down. It comes to the Earth's surface. It basically drops down a little. When that happens, the water droplets that are there would scatter the light even more. That is why you can't see on a foggy day. That is the reason there's scattering of light happening. That is why you can't. Have you ever experienced this? Even if a person is standing in front of you, maybe maybe 2 or 3 meters, you can't still see him. Have you guys ever experienced that at least once in your life? Like, even if the person is standing right in front of you, you still can't see him. Why? That is because of scattering of light. Light gets scattered so much that you can't see a person who's right in front of you. That is what causes accidents and all of that. Again, that's because of scattering of light itself. All right. So anyways, once again, here's the leaderboard, guys. Krishna ji on the top, followed by Abir, followed by Arav, followed by Anmolpreet, Sakura. We have Kushi. Okay, no. Anmolpreet on the second, third is Arnav. Then it's Kushi, Abir, Sakura, Krishananda, Rishikesh, Haloda, I'm good. Taiba and Sakif. Congratulations. Well done. All right. What is my name? My name is Batman. I'm Batman. All right, fifth question. Let's go. Fifth question, let's go. Is it Ansha? Very awesome. So many Mallus out there. So many Mallus these days. All right, here's another one. The danger signal installed at top of tall buildings are red in color. These can be easily seen from a distance, because among all other colors, the red light is scattered the most by smoke or fog. It is absorbed the most by smoke or fog. It scatters the least by smoke or fog. It moves fastest in air. What is the reason that the danger signals installed on the top of the building are red in color? All right. Let's go. Oh, 20 of you guys got it right. Congratulations once again. Violet gets scattered the most, red gets scattered the least. That is why it is able to travel a longer distance. That is why we use that as a signal to, avert danger, or to show people that, there is some sort of danger in the front. It's because it gets scattered the least. That is the reason. So it can travel a longer distance. So people who are far away also can see it and, take the right decision accordingly, right? Anyways, 57 of you guys got the right answer. Congratulations. Again, half the class. 31% went with it gets scattered the most. Guys, violet would get scattered the most. Violet, indigo, blue, those would get scattered the most, but red, on the other hand, would get scattered the least. All right, so please don't ever get it confused. All right, anyways, here is your leaderboard one more time again. Krishna followed by Anmolpreet followed by Arnav, followed by Kushi, followed by Abir, Sakura, Rishikesh, Kritish, Amisha, and Kavin. Congratulations. Well done, people. So that is your second last question. You guys have already lost the bet. I already told you guys 75%, and that was more than 3 questions. Oh, 3 questions at least. You got, I believe, 1 question so far, or 2 questions. 2 questions? Yeah. Last question, the last and the final question. All right. 6th and the final question. Here we go. To end today's session. That's it. Here it is. The question is: these are examples of phenomena of scattering of light, except which one? Which of these is not an example of scattering of light? Options are: sky appears blue at midday, sky appears reddish in the evening, rainbow after rain, or all of the above. Which of this is not an example of scattering of light? Yes. Sure, Ranjanji, sure. No questions are silly. No questions are silly, but yes, definitely I'll take up a session for that also. We'll do some chit chat in that session for sure. We'll also rag some people for sure on that day. 16 of you guys got the right answer. Congratulations. Well done. Again, confusion. I don't know why. Why is it, people? Okay, are you guys still confused about scattering and dispersion now? Are you guys still confused about scattering and dispersion? Again, people, let me repeat this. Dispersion is splitting of white light into 7 colors. That is dispersion. Scattering of light is when light is getting spread, or it's getting, or the direction of light is changing. The direction of light is changing, or the spreading out of light into different direction because of the dust particles, the gas particles, the water molecules. That is what is called as scattering. So when you talk about rainbow, that happens because of dispersion of light, not scattering. There are 3 important things. One is refraction. In the case of rainbow, refraction, total internal reflection, or in your NCERT also given as internal reflection, that, and finally dispersion of light. So these are the 3 factors that helps in the formation of rainbow. It has got nothing to do with scattering of light. All right. Scattering of light leads to the sky color being blue. It is the reason why you have, during the sunrise and sunset, you have yellow color or orange color of the sky. All of that is because of scattering, not because of dispersion. All right. Anyways, so here we go, people. Krishna is the winner for today. Look at that frog. Look at that frog staring down into your soul, asking you, did you do the right thing? But yes, Krishna, congratulations. Well done. Second is Anmol. Third is Abir. Then it's Kushi, followed by Vedantu, OP, followed by Rishikesh, I believe, followed by Kritish, followed by Sakura, followed by Krishnanda, and Amisha as well. Amisha, welcome to the leaderboard. Super awesome, guys. That's all. So yeah, people, that's all for today. That is it. We are done and dusted. Do not forget to like, share, subscribe. And yes, let me know if you have any doubts. And yes, guys, this is your homework for today. Let me know what is the answer in the comment section. The question is this: the deflection of light by minute particles and molecules of the atmosphere in all direction is called as dash. The deflection of light by minute particles and molecules or at an atmosphere in all direction is called as dash of light. Let me know what is the answer in the chat box. All right. So yeah, guys, that's all again. So can I have a question? Can you please answer? Yes, Shreyaji, tell me what's your doubt. Guys, whatever doubts you have, this is the time for you to put it down. If you don't have any doubts, thanks a lot for joining. Do not forget to subscribe to the channel. Stay safe. Stay hungry for more knowledge. Peace out, people. Peace out. All right. So let me know what is your doubt. So which planet reflects max light? Venus. Venus is the one that is the brightest among all the planets. And the reason why it's so bright is because of the fact that the atmosphere of Venus reflects a good amount of light. And also there's a lot of a lot of carbon dioxide in the atmosphere of Venus, which makes the planet very, very hot. So there's a lot of greenhouse effect happening, and the atmosphere also reflects, the atmosphere of Venus also reflects a lot of light, which makes it one of the brightest planet of them all, right? So how to understand which color scatters the most or the least and disperses the most or least? Okay, Jayanti, just understand this, that violet is the one that refracts the most and gets scattered the most. All right, scattered. Refracts also, it does the most. Scattering also, it is the one that gets scattered the most. All right, scattered the most. The reason why it happens is because violet has very, very less wavelength. All right, red is the opposite. Red refracts the least. It has less. This is something which refracts the most, and red is the one that refracts the least. So this is most refraction. Red, on the other hand, would refract the least. Red would refract the least refraction and least scattering also. Refraction, wide. All right, my handwriting is like, if you guys ever want prescription, I can tell you that. Refraction, because my handwriting is just like a doctor's handwriting. All right, least refraction and scattering of light both happens because it has higher wavelength. So what you see is that when you write WebG or no, the wavelength is slowly increasing. So as it goes up, so that means that violet has the most refraction. Indigo will refract less than violet. Blue will refract less than indigo. Green will refract less than blue. So it goes on like that. So it's an ascending order. So least is violet, and as it goes up, it goes to red. It's like that. All right. When is the next session? It'll happen pretty soon, buddy. I think tomorrow also I have a live session. I'm pretty sure. Sir, I want the Vedantu Pro subscription, but can't afford that much. What should I do? Shreyaji, can you do one thing, da? Can you just send me an email? Yeah, just send me an email. I'll see what I can do from my side. Just drop an email to my email ID. Yeah, just send me an email on anup.manoran@vedantu.com. All right, just send me an email on this email ID and I'll see whatever I can do from my side. All right, don't worry. Which is the best engineering stream for ISRO? Anubhav, ISRO requires all the streams of engineering. It's not just one. They require mechanical engineers to electrical engineers to aerospace to aeronautical to computer science to IT engineers, pretty much everything. They need all, they require all sorts of engineering, from all engineering aspects. Because when you're working in aircraft, it's not just one thing. An aircraft has a lot of factors. It's not only the astronaut. It depends on the electronic equipment. It depends on the aerodynamic shape. It depends on the material that you use. So you also need structural engineers. The kind of material that you use, even that is also important. So many factors are there, because to make an aircraft, to make a spacecraft is not easy. It's not a one-man job. It takes an entire village to make it. So there's nothing like best engineering course. But if you ask me as a personal opinion, I would say that mechanical is a more diverse engineering field, because if you take up mechanical, you have an option to change to whatever stream you want later. So that's one good thing about being a mechanical engineer. So if you take up mechanical engineering, let's say after your 4 years of engineering, you want to get into aerospace, or you want to get into structural engineering, or you want to get into aerodynamic, you can choose that field. So a mechanical engineer would have a larger aspect, you have a larger choice, larger set of choice that you have. So that's the only thing. All right, but yeah, all engineering's degrees are pretty much the same. All right, wavelength increases, speed increases, refractive index decreases, deviation of light. Exactly. Exactly. This is the Brahmastra, as Abir said. Just remember that. Exactly. That's all. So don't know anything. How can I get 90+%? Any tips from you, sir? Start reading the textbook. Start reading the textbook, and if you can, enroll into any of the course, any of the crash course. I'm not saying this to because I work for Vedantu. It's not like that. It's going to help you a lot, because if you haven't started yet, a good way to start would be from a regular session, so that you get an idea of what is important and what is not. Because what happens most of the time is that you don't have a guidance. The majority of the cases where you're confused about what to do next is you don't have a guidance. So when you have a person to guide you throughout, it'll make your journey a little bit more smoother. You'll understand where should you put effort, because at this point of time, the time is very limited. You have about 1.5 months studying the entire spending a lot of time on on the parts that are not needed will only be wasting your time. For example, I'll just give you an example. Refractive index. It's a very, very small topic. Now that part of that chapter of light reflection and refraction, refractive index might be for 1 or 2 marks. Max to max 1 or 2 questions might be asked. it's not wise for you to spend 5-6 hours on it. It's not wise. So understanding and doing smart work is more important, because it's not just physics right now. You also have to worry about a lot of other subjects also. You have a lot of other subjects. You have chemistry, bio, English, social science. You have a lot of other subjects. You need time for that also, right? It's not just physics, right? You have all the other subjects also. So working smartly is also very, very important at this point of time. So a crash course would definitely help you out a lot, buddy. All right. Okay. Anything else, done? Hi, Jayani. All right, Jay Uni. It's Joyani. Hi, Jayani. What's up now? All right, yeah. Oh, is it? All right. Are Shreyaji, why? What happened? Why? And what is that named? What is that name? All right, Shreya. All right. It's okay. I don't know why did they give you a timeout. So can you please tell your actual place in Kerala? I stay in a place called as Kayamkulam. It's near Alappuzha district. It's like 100 kilometers from Trivandrum and about 100 kilometers from Ernakulam also. Like about 100. It's about 3 hours journey from my place to Ernakulam. Like Kochi and all. It's about 3 hours drive. So my physics and math are strong. So what is best for me? Anubhav, all right. That is okay. Anubhav, to be very honest, I would request you to wait until your first year of college is done. Don't make a decision right now. Make sure you go through at least the first one as well. That is, go through the first year of engineering. First year of your first PUC or plus one, whatever you call it in your state. Plus one PUC, that is pre-university college. Plus one, plus two, whatever you call it. Please make sure you wait till that one at least, all right? So you still have 2 years time. If you're in 10th standard right now, you still have 2 years time to, to make that decision. You don't have to make it right away. So the thing is this, that every year the stream is changing. Every year the importance for a certain field is changing. So in 2 years time, God knows what's going to happen. Maybe there might be more importance given to a certain degree in that next 2 years of time. So keep an open mind, keep researching about all the fields that you have around you. You have to have an open mind. Understand what are the things that is going on around you. Understand that which and all college offers good, that particular degree that you want. Look for all these kind of things, because you have a lot of time. You still have 2 years time. Utilize that time to understand what's going on around you and then come to a conclusion. But you don't have to rush into anything right now. You still have 2 years of time, right? How to study for term 2 exam? You have time for that, Witness Society. Let's get through term 1 examination. Let's see how it turns out. Then you can start preparing for your term 2. Because if the exam happens, let's say in the month of November or December also, you still have Jan, Feb, March. You still have 3 months time to complete 2 chapters. In physics, you only have 2 chapters. Electricity and magnetic effect of electric current. So there are only 2 chapters. Aram, so you can finish off in 2-3 months. Aram, so you'll become an expert in 2-3 months. So don't worry about it, right? How to join Menti in computers? Saket, you have to open up a new tab and enter it. Sir, but I wrote notes of you. Then that's more than enough. That's more than enough. See, that's what I'm trying to tell you. If you have a source, then don't think about anything else. If you're finding these YouTube sessions helpful, you're having the notes, you're noting it down, then that's more than enough. Prepare those notes, but make sure you read the textbook also. Make sure you read the textbook as well and make notes on your own. Like, write your own notes also at the same time. Because anyways, for one thing is that in that next how many ever days that you have, 40-45 days that you have, you probably have 2 chapters from each subject, 2 to 3 chapters. How many chapters do you have in mathematics? Anyone? So what about the data sheet of term 1? What do you think about the data? What data sheet? What data sheet are you talking about? Like, you're talking about the marks? You're talking about the mark sheet? I'm not really sure. Sure, Anubhavji. Hi, Akriti. Arey, Akriti ji, what's up? Yeah, but yeah, what I'm trying to say is this, that 4 diaries. Oh, Arey, then why are you getting demotivated? Then you're prepared. No, then you're prepared. Build up that confidence. Now if you're prepared about it, then you don't have to worry about anything. Don't think about all these factors. See, guys, I don't know what do I say. It's like there are so many things that can go wrong. I understand there are so many things that can go wrong. But thinking about all the things that can go wrong will only make your life more difficult. It'll only make your life more difficult. Rather than making your life a little easier, it will only make your life more difficult. If you think about all the things that can go wrong, you are prepared. You have 4 diaries, you have 4 diaries of your own notes. Then why are you demotivated? Why? because you're prepared. There's nothing that, see, if you have done so much of work, then that means that you're thoroughly prepared for the chapter. All you need to do is build up that confidence. How do you build that confidence? Solve sample papers. Solve as many number of sample papers you can. Solve as many number of sample papers you can. Keep solving questions. The more confidence you build, no, the easier it gets. It's not that you don't know the chapters. It's not that you don't know the concept. It is just that you need to build that confidence. So practice as many as you can. 10 chapters, my God, okay, it's a lot. Okay, no, for your term 1 examination, you have 10 chapters. For your term 1 examination, you have 10 chapters. My God, that's a lot. You took it. Array, nice, nice. It is a beautiful place, da. Study array, you have to focus on the concepts. You have to focus on the concepts. It's very important to know the concepts, because if you see physics also, no, majority of the questions were all application based questions. It was not direct direct answers. They were all application based questions, applying your array diagrams, applying your applying the concepts that you have studied when it comes to scattering of light, Tyndall Effect and all of that, dispersion and all of that. So it was more application based questions. So my suggestion would be that start focusing on the concept a little bit more, buddy. Read the textbook and try to understand the concept. If you don't understand something, use your YouTube. You have a certain concept that you're not able to understand, use your YouTube. No, there are a lot of free softwares also for lenses, for mirrors, to try out the ray diagrams. You have lots of free softwares. So try those softwares out, try out those things. It's absolutely free. So use all these free tools to prepare for yourself. That's it. All right. All right, Kab, I really don't know, Banmeet. I think the next session is tomorrow. I'm not really sure though. I have to check it. Today's your birthday. Arey Abhiman, happy birthday. So guys, I have to leave right now. I have another session, but I will mark in reader. Is that okay? Yeah, as long as it is helping you. So the whole point of making notes is that during the time of exams, you should not look around for the answers. The whole point of having an exam is, or having your notes is, so during the time of your exams, if you just refer the notes once, you should be able to understand and remember everything. So that's the whole point. So reader, you're using a marker, whatever it is, as long as you're able to do that, that's more than enough, right? So yeah, guys, that's all. IIT Delhi, array, awesome. You can definitely get through it. Don't worry. Start preparing. That's all. Start focusing. If you're serious about getting into IITs and all, you have to start making your concepts very, very strong. Because to prepare for IITs, it's all about conceptual clarity. It's very important to have a very strong concept. All right. You have to start focusing on the concept. Please start focusing on the concept. Try to understand the focus, all right? Oh yeah, sorry da, Shreya, 1 second. Sir, I do study, but seriously, to be honest, I forgot. Okay, then please revise. I'll tell you about revision. Guys, you know what? I'll come up with, I think tomorrow, I have another live session where I'll be talking about some of the study strategies. So join that session. We'll have more conversations about this. I'll tell you how to prepare for your exams. What are the things that you can do? We'll have a detailed conversation about it. I think tomorrow again at 3 p.m. I'll be coming live. So you guys can, join that and we'll talk about it, right? All right, thank you. All right then, sure. All right, just join tomorrow's session. We'll have this detailed conversation and see what we can do. What are the things that you can change a little to make that journey of yours a little easier, right? So yeah, guys, that's all up. All right then, take care, guys. See you all in the next section. Take care of yourself. Stay safe. Have a great evening. Bye for now. Enjoy yourself. Have a wonderful day ahead. Bye, guys. Take care. See you all.